Hello, Sheldon McDonald here. So now we're going to start looking at RsDosTool's function library and how you would use that with your code. Um, so we're going to go ahead and load a disk image in. Let's just look at an example one that I've got together already. Oops, let's go to the desktop. Okay, so we have my game, for example. So we go to the program editor, and so at the start of my program listing, you can see that I've typed in include main.txt and include semig8.txt. And you can see down here, it's actually got some commands from those libraries, okay? They've all populated down here. When you click on them, it tells you in the gray square down here how those commands are used, okay? So let's start off with let's go ahead and do a new project, okay? Um, so let's go to the program editor and we'll say new. Okay. We're going to save this one on disk 2. So the way that let's refresh this so these are empty. So this is a brand new project. I'm going to start off by saying include, hashtag include, main, and this doesn't need to be in caps either. Let's go include tab main.txt, okay? And then we're gonna load two of them. We're gonna say include tab semig8.txt. Okay, so because this is a brand new project, it hasn't shown us anything from the assembly help down here. But since it's new, we have to actually load them in manually. So we can click on this help button, and you'll see that there's 3 libraries so far. I have main.txt, semig4, and semig8. So let's go ahead and load main, and you can see it's populated the functions that are in that library. Okay, and then I can go ahead and load semig8 in. And so now it's expanded quite a bit, and we have a couple graphic routines for that display mode. Okay, so the way this works now, let's start typing a little short program. We'll say originate at 3000. Okay, we have a start and an end to our start. Okay. Remember, you got to tabulate everything. You cannot use space. It is very important that you tabulate between include and main. If you use a space, it will not pick up the file name. It is very sensitive. It needs to be a tab. Okay. So if we type in, so if we want to set the display mode, we can see down here display mode. Display mode, display. So let's type that in. Display mode bracket. If I was not selected on it, it'll bring it back up. Okay, so let's say I'm there and I just finished typing it in, it'll load it down here. Okay, so that's kind of nice. If you typed it in wrong, nothing will display down there. And you can look it up on the side to see if you wrote it in right. Okay. So in this example, display mode, only 2 modes are supported at the moment. We got SG4 or SG8. So if I type 8 in and close it out, that'll actually set SemiGraphics 8 display mode. Okay. Now let's say we want to clear the screen. From the SemiGraphics 8 library, it has CLS SG8. So I can type in CLS SG8, and it says it accepts a number from 0 to 8. So if I type in 0, it should be black. Okay. The next one we can take from this library. Let's use the print, the SG print. This is only going to work on a color computer 1 and 2. On a color computer 3, it'll just show either a big green space or a big black space where the letters would have been. Okay, as far as I understand, the GIME chip, gimme chip, whatever you want to call it, the X version that Ed Snyder's working on should bring back the text. But just know that if you're using this command, it's only going to work on an emulator or on a color computer 1 or 2. So let's go ahead and try this out. Let's say print SG8. Okay, so it's come up with a couple things down here. C is for if you're starting in caps mode or not. And then we got the X position, Y position, and the string. So let's say we're going to start off with lowercase. We'll start right at the top of the screen. And maybe we want to say hello world. Okay. This is an acceptable command in this editor. Okay. Just because we have it loaded in the library. Now we can close this out. We can put key, in key string, and BEQ to key. So what this will do is create an infinite loop if no key is pressed. If you look at in key string, it's actually, it says here that it returns a key press value into the A register, 0 if nothing. Okay, so that will create an infinite loop, and then we can RTS out of it. Now, how do we know for sure that we're in SemiGraphics 8 mode? Let's throw a little more in there. Let's put a line. Let's say line SG8. Let's go from 10 and 10 to 30 and 30 on the screen. And we'll change the color to orange. And we should have a line now. Okay. We could, yeah, so this will show us that it's in SemiGraphics 8 mode. I mean, we could put 2 lines in. Line SG8. Let's do 10 across and 30 down to 30 across and 10 up. And we'll make this one red. Okay, so this will kind of show us that it's in fact in SemiGraphics 8 mode. We'll save this. We'll assemble it. If any errors occur, they'll pop up. They didn't. So let's have a quick look at the program editor. What happened here is that it actually it commented out our 2 libraries, and it did a little bit of programming for us. It filled in those blanks, and it brought in those functions. Okay, and it just renames them all. Okay, so it made this program a hell of a lot bigger than it was. All you got to do is reload it back in to see what we had. And you can see how this is going to make assembly language programming that much easier and that much faster. So we've got our program now. Let's save this disk image. We'll save it as test A, save. Overwrite it, yes. Let's load that disk image into VCC. And let's see if that's actually working. Okay. So I've changed my cartridge already to test A. So if I go dir, we should have those files in there. Let's load m new prg, and I will execute. Now we've got our 2 lines. Okay, we've got our orange line and our red line. Note that this is completely the color problem is completely the emulator's problem. Okay, if this was on a real color computer, you would have the proper colors there, okay? And that black should have actually been red. So this shows you that we've in fact changed, we're actually in the SemiGraphics 8 mode, okay? Let's do another quick test of this. Let's look at how we can use some of these functions for quick, quick data, like say I need to print a value to the screen or something. Let's say load D. Let's say D has the number 65535, okay? I want to display that on the screen. That isn't actually very simple to do in assembly. You've got quite a bit to translate 2 bytes into a human readable string. So we're going to go over how we can do this with a function library that is located in main.txt called strstring. So we're going to make a variable. We'll call it wstring, and we're going to say this is an FCN. It has to be an N, 0 terminated string, and we need 5 digits, okay? This is how we can create a string that we're going to be able to read. Now what I'm going to type in is strstring in brackets, and this should come up in the help now. It says word, which means that it needs a D value. We could just type a number in here. I could type 65535, or we can just type D, and that will pull the D register into the string. Now I want to, it says return string in boxy brackets, so let's do a return string on wstring, okay? So that means the result is going to end up right here, and it's going to put 65535 into those digits, okay? Now we want to print that value to the screen. I can say print SG8 bracket. Maybe we want this in caps mode this time. So we'll say 1. We'll say 0 and 1 down. And let's type in, this needs to be in boxy brackets this time, wstring boxy bracket. Okay? Now that should print 65535 right underneath. And something we can do just for fun, in this loop, I could do some changes to that. We could make a counter, okay? So let's put a counter in. Let's go add D 1, okay? And then right here, I'm going to say print SG8, and then we're going to say 1 and 0 and 1, and the W string. Okay, we're going to delete this one. Okay, and we're also going to have to move the str string into the loop. Okay, so I'm going to delete this LDD as well. Okay, actually no, we're not. We're going to put that back in. LDD, let's just say 5. Okay, or 1, whatever. 0. We're starting it off fresh. Okay. Now we're going to add 1 in the loop, and then we're going to strstring D, and in boxy brackets it's going to return to wstring. Okay, and then this one will print the number to the screen, and then look for a key press and infinitely loop. Now if we have too many commands in between here, you might even have to type large branch equal, but this should be small enough to fit into a BEQ. So we're just going to leave that as is. We're going to save this, and we're going to assemble it. Okay. So it's now assembled. Save disk. We're going to load VCC in. Make sure you close VCC down every time, or else it will lock that file down. Okay. Load M, new PRG, and execute. we should have a counter. It doesn't look like it's counting though, so we need to have a quick look to see why that is. So let's close that. Let's have a look at our code. Add D1, store str string dw string. So the problem here is that D is not being saved anywhere, okay? So we actually need to create a variable. So let's say, let's just say num. And then we can say fcb 0, 0, okay? So instead, now we're going to be loading D from num, okay? And then we're adding D to it. Instead of that, we're going to say, let's move this down. Let's increase D 1. Increase D 1, okay? Oh, sorry. Increase D. Oh my goodness. Actually, that might not work. Let's just do it this way. LDA num. Sorry, not LDA. LDD num. Let's add D 1. And then we will store D at num. Okay? So that will take the number, add, and store it. Now this counter is going to work. Okay? So, yes, this all looks good to me. We're going to save this. We're going to assemble it. That was, oopsie. Assemble it. Okay, and save disk. Now we're going to go to VCC. We'll load that back in, and the counter should actually be working this time. So that's one thing to keep in mind, is that using functions changes your registers, okay? It's not going to remember what you had in there to begin with, okay? So let's put new PRG in. We will execute, and we should have counting numbers, right? And as you can see, this is much faster than BASIC. But you do have to keep in mind there's actually a lot of code to convert a byte or 2 bytes into a human readable. There's actually a lot of code to it. It's not a simple command. I've made it into a simple command, but this is not an easy thing to do in assembly. You actually have to make a program to do it. Okay? So there you go. There you have it. That is in SemiGraphics 8 mode. And that kind of showcases how the libraries work, okay? And I'm going to keep working on them. I'm quite a busy guy. I'm working on this. I'm still working on the RsDosTool itself. And I'm even working on a game project. All right, thanks for watching. Ask if you got any questions or comments, and it'll be interesting to see what you guys have to say. We'll talk to you later.